Okay, this is section 8.5. We're going to repeat a little bit of stuff. So far, one of the things we should know how to do, you can just watch for a moment. I'm going to repeat a couple things off the last lesson. But if we were to multiply these, we should know how to multiply these. It's the distributive property. We take x times x, we get x squared. We take x times 4, we get plus 4x. We then take 3 times x, we get plus 3x. And then we take 3 times 4, we get plus 12. Now what you notice is those two are like terms. So those two, we get x squared plus 7x plus 12. Now that is what we call multiplying. Yesterday's lesson, or the lesson before this, I should say, is on what we call factoring, and you will start with a problem like this. And you'll be asked to break it down. Now notice, I'm doing this on purpose. That happens to be this one. We're trying to break it down. So to break it down, we're trying to turn it into two binomials, two sets of numbers. We already know the answer, but I'm going to show you how we get there, what the lesson was about prior to this, because today's lesson is pretty short. First of all, we recognize that to get x squared, we would take x times x in those two spots. If we were to multiply it, that would get us x squared. But next, I taught you that we look at this thing backwards. So I'm going to look at the last number. I'm going to look at the 12. And what we did yesterday is we decided, how do we come up with all the possible ways to multiply to get 12? For instance, 1 times 12 is 12. Well, I said we'd take our calculators and if I divide 12 by 1, it tells me that 1 times 12 would be 12. I'm going to take 12 divided by 2. So 2 times 6 would be 12. And 12 divided by 3, 3 times 4 would be 12. Now, I don't continue to go on. One of the rules as you're writing this, you might say, why didn't you put 4 times 3? We already have it. We don't repeat it. Once it loops around and we get a repeating number, we're not going to continue. But now we look at this and we look backwards. Since factoring is working backwards, we read backwards and we look next at this sign, the plus sign. That tells me they're going to add to be positive 7. The two numbers that can add to be 7 are 3 and 4. And if they add, they're always the same. So if that one's positive and that one's positive, they would add up to 7. So I'm going to go plus 3 plus 4. You might say, what if I went plus 4 plus 3? Same thing. It's fine. But that ends up being the factored answer. And notice we just got back to the original thing that we had before. So I'm going to look at one on yesterday's notes yet. The lesson before, I'm going to look at C, and it says x squared minus 36, x plus 35. We did this one yesterday. Again, this is a short video, so we're just going to repeat a little bit because it's so fundamental to today's lesson, we have to understand it. I'm trying to break this one down, x times x, but then 35. So I take 35 and I figure out what are all the ways to get 35. 1 times 35. Always can start with 1 times the number. Then we keep going. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 works. 5 and 7 will be the next one. I'm going to keep going. I'm going to divide by 6. The rule is, since I divided by 6 and I got a number that's smaller than what I divided by, I can stop. Because 5.8 is smaller. So there won't be any more. The next one would be 7, and we already have it anyway. So we've gotten to a point 5 times 7, that works. But now we look, as we read this thing backwards, they have to multiply by 35, but they have to add up to be negative 36. Well, what numbers add to 36? 1 and 35, we get a negative and a negative, because if they add up to a negative, they're both going to have to be the same. Negative 1 and negative 35 will add up to be 36. So we put minus 1, minus 35. Now, one of the things I always tell students to check, to me it kind of looks like a mouth and a nose. Those are the eyes then. But if you check this, x times negative 35 would be negative 35x. And negative 1 times x is negative 1x. That's negative 36x. Okay. All right. So now, let's do one more from yesterday. Because sometimes we have ones that are negative, like in E. X squared minus 3x minus 18. X times x. They have to multiply and become 18. All the ways to get 18, 1 and 18, 2 and 9, 3 and 6. So this time, they have to subtract to negative 3. So you read it backwards. They have to subtract and get negative 3. If I subtract those, I can get 3. But how do I get negative 3? If I have a positive 3 and a negative 6. Now if I check these two, that's negative 6x. These two, that's positive 3x. I put them together, it would be negative 3x. That's what I wanted. So this here is my answer. Okay, what's new today though? Really, nothing. It's just putting a couple things together that we already know. We have a little bit different problem though, because we're going to use the GCF to factor it out of here. With each of these numbers, what number could go into all of them? Remember, it can't be bigger, like 18 can't go into 2. The smallest one is the most. What number can go into all 3 numbers? 2. So we call that the GCF, the greatest common factor. So first we're going to factor that out. So we have 2x squared plus, what would I multiply 2 by to get the 12x? 6x plus 9. 2 times 9 is 18. So first, I factor out the greatest common factor. That's the only piece that is different from yesterday. Now, that 2 is always going to be there, but the rest of this, I'm going to take this one, and I'm going to factor that one like we did yesterday. So the number I'm now looking at isn't the 18, it's the 9. So 9, we want to think of all the ways we can multiply to get 9. We can, of course, take 1 times 9. 2 doesn't work. 3 times 3, that's all the ways. After the 9, read it backwards and say, whoa, they have to add up to 6. So if I make x plus 3, x plus 3, positive 3 and positive 3 make 6. This one, factor out the greatest common factor. What can you take out of there? 3 can come out. We have inside n squared plus 9n plus what? 14. Good. Now that 3 stays out there, and we have to factor the rest. So we have the 14. We need to break that one down. 1 and 14, 2 and 7. With the 14, they have to add up to 9. 7x, 2x, those add up to 9x like we want. So that is our answer. The 3 is out in front. All right, we try this one. What can we take out of all of them? Do that first. But there's something else that can come up. So I can take out a 2 and a D. If I take out the D, all of them got to come down by 1. This becomes D squared because it was D to the third. This becomes 2D because 2 times 2 is 4. D times D is D squared. And 2 times negative 15 is negative 30. So the 2D will sit out in front. D times D is D squared. Now we have to somehow make them become 15. 15 is 1 times 15, 3 times 5. They have to subtract to be 2. Now you always have to look in here. We don't want to look at the original, because the original, once we factored it, that's done. They have to subtract to be 2. So 3 and 5. Which one's negative? The 3 is negative, correct. Because 5D will be positive 5, and then minus 3 leaves us positive 2, and we want positive 2. And that's what we have there.